So hey guys, welcome back to another module in this full machine learning course. So today we're going to introduce the topic which is the probability and the statistics, which is the main topic in the machine learning course, and how these will help in our predictions and a lot more stuff in the machine learning. So many of the instructors will just leave this topic and leave it to the students, but I just want to cover like detail like anything, okay? So I hope you love this lecture. So if you love this lecture, please like this lecture and share with your friends, okay? So we're going to cover, first of all, we're going to cover the probability. So what do you mean by a probability? This is one of the biggest question, right? So what do you mean by probability? So it's just a branch of mathematics that deals with the study of random phenomena. So it's just a branch of mathematics that deals with the study of random phenomena. Means like describe the likelihood that certain events will occur. Means like it just a kind of it deals with the uncertainty. Means like it describes the likelihood. Means like this might will happen, this might will happen. There is a 50% chance of winning this game. There is a 60% chance of Dhoni hitting a six. I hope you're having a basic understanding like what is the probability. Okay, so it describes the likelihood of a certain events will occur. Means like Dhoni hit a six. It's just a probability. It's a likelihood that will occur. So and assigns a numerical values to represent this likelihood. Means like this 0.5 means a 50%, or like a 0.7 which is 70% of chance of hitting a Dhoni six. Okay, so I hope you're having an understanding like what is this probability. And we have a two main types of a probability over here. We have a classical probability and we have an empirical probability. So like what do you mean by a classical probability? So it is based on ideal equally likely outcomes, and it is calculated by dividing the number of favorable outcomes and the total number of possible outcomes. Means like, so it's just a kind of a classical probability. Means like we have a number of favorable outcomes. So as of now just ignore like what are these like. So I just want to cover it again like. So as of now just leave it. After telling the probability you have a basic understanding, and I'm just giving the notes for the free. So if yes, then comment down below like I just want the notes, and I just ping the notes over here on a reply, okay? So the probability can be expressed as a variety of ways. So it can be expressed in a variety of ways, like including decimal. So as I said, in it including in a decimal or a percentage or a fraction. It may be like anything. So for example, a probability of 0.5 can be represented as 50%, and 1 by 2, this is also 50%, right? And this is also 50%, and 0.5 is also 50%. I hope you're having a basic idea like how these expressed in a such a way that all are equal. All are equal. Okay. So it's just a mathematical framework that performs a certain number of actions where these actions contain some sort of uncertainty. Means like this is a framework, this is a mathematical framework that performs a certain set of actions. So what are those actions? These actions contain a level of uncertainty, level of sort of uncertainty. So what do you mean by uncertainty? Means like we are not sure, that this might be happen. We are not sure like this will happen or not. So I hope you're having a basic understanding like what is going to do. So for example, we have a whether the person have a cancer or a fever or not, or like whether the Dhoni will hit the six or not. We are not sure. We are not sure that whether the Dhoni hit or not, but there is a chance of 70% that Dhoni will hit the six. Right. I hope you're having a basic intuition about this probability, like how these gonna like give the mathematical framework. I hope you're having a basic understanding. Okay. So usually the probability is expressed in a range in between the 0 and 1. Means like the probability is always 0, between 0 and 1. So 0 means like no probability, and 1 means exact probability. Means like there is a 100% chance. So there is a 100% chance that the Dhoni will hit 6. If 0 and there is 0%, there is a percent that Dhoni will not hit 6. Okay, I hope you're having understanding. So the probability is between 0 to 1, and the 0 is will not happen, and 0 and 1 is will happen. Okay, so why we are studying probability here? We have, as I said, now these are the important in the machine learning and artificial intelligence, data science, and a lot more. And this is related to in our real life problems also, real life problems also. So I just wanted to give a practical example so that it will be easy for you. So it helps in a machine learning to predict the future events based on the past historical data. So this is also used in our real life problems, like means like I just want to give a practical example like how this is gonna relate to our real life. Means having a cold, having a body pains, and having a fever, and having a throat pain, and all these based on these historical data, we can say there is a probability of getting a corona. Means like there is a probability of getting a COVID. I hope you're having a basic understanding. Like, so there is a probability. Maybe you have a 50% chance or a 60% chance that might having a COVID. Okay, so based on these data, we can conclude that the person has a COVID or not. Right, so this the probability is related so much in our real life. So I just want you to explore a lot of examples out there. Okay, so it helps in machine learning. So we make predictions, right? In machine learning we make predictions, and the predictions are based on our previous data, right? Previous or historical data. Based on that we make predictions. This is a supervised learning. This is a supervised learning. We make from the output, we make from the past data. We make predictions from the past data. This is a supervised learning, and we're going to cover in our machine learning lectures. I hope you love those lectures also and support these lectures. Okay, so I just want to give a detailed graph over there. So the probability theory is used in a statistics and the machine learning. Okay, so these two are used in a machine learning. This is a best graph out there. Okay, so the probability builds a base concept between these two. Means like this probability builds the base concept. Means like in the statistics and in the machine learning, this builds a base concept. I hope you understand this. Okay, so this is a detailed introduction about the probability. So I just want you to explain it again so that it will be easy for you. Okay, so what do you mean by a probability? So the probability is just a branch of mathematics that deals with the uncertainty. Means like it might be happen. Means like uncertainty means like what? Means that you are not sure that will happen or not. Okay, so it deals with the uncertainty of that event. Okay, so if we are tossing a coin, and there is a probability of getting a heads, there is a probability of getting heads and getting tails. There is a 50% chance, right? So we just simply write the probability of getting head is 0.5, and the probability of getting tail, which is equal to 0.5. So this is used in our examples, right? So it just we have a, so I just want to give this also, and we going to, as of now, if you didn't understand also, totally all right. So we're going to cover in our detailed lectures out there. Okay, so this is a classical probability. So what do you mean by classical probability? Means like, so like it is calculated in dividing by the number of favorable outcomes by the number of all possible outcomes. I hope you're having a basic intuition about this classical probability. Like, so number of favorable outcomes. So we have a number of favorable outcomes, and then we simply divide with the number of possible outcomes. Okay, and we have an empirical probability, which is a frequency of events observed in a sample of data. Means like it is based on the frequencies, okay, in a sample of data. So as of now, if you don't understand that, so it's totally all right. We're going to cover in a great detail in our further lectures. Okay, so in our next lecture we're going to cover, so I just want you to familiar with the terminologies we're going to use in our probability. So I just want to, I have given a beautiful notes out there. I just typed it, this total, it took around like a 6 hours to make all these beautiful notes. So I hope you love this lecture, right? So we're going to cover a great detail way. We have beautiful graphs out there, and what is histogram, and we have a density plot over there, and we have expected value and a lot more stuff. We have a measures of tendency also. So I hope you love this lecture, and tomorrow onwards we're going to start with the terminologies. So I just want you to be familiar with these terminologies. If you are familiar, then it will be easy to teach in a fast pace, so that we should move further. Okay, so we don't have any time, like, so I just want you to complete this course by the end of the February or March. Okay, so I hope you love this lecture. So until then, bye bye. See you in the next lecture. So in our next lecture we're going to start with the terminologies. So see you there.